So what I want to show you right now is how to identify your vertex when given an absolute value function. So in this case, I'm giving you f of x equals the absolute value of x plus 8. Again, this is something that we've seen in class and we have graphed it. So if you're not sure what the graph looks like, I highly suggest you go back to the notes previously. But we need to identify a vertex. And a vertex is what creates the point that creates the two lines. So in other words, what I mean by that is if I drew an absolute value function, this right here, this little point, okay, that is my vertex. It's not going to have a point like that every time, but I'm just exaggerating to show you that anytime I have that little dip right there, that point right here is my vertex, no matter what. And we did a few of them yesterday, so hopefully if you can go back to your notes, you can see that there was a point every single time we created these, okay? So again, I'm trying to identify what that is without even graphing the function. So what I'm going to do is I look at my vertex, or I look at my function, and notice that there's nothing inside my absolute value. I have the absolute value of x and then plus 8. So technically there could be something inside my absolute value. In this case it could be x plus 0. And that's something for me to know, because if there's nothing in there, then my vertex is going to contain 0. And then if you look on the outside right here, we had 8. Okay, so that is the last part of my vertex. I know that I didn't move left or right any, because there's nothing inside this absolute value, but this 8 told me that I'm going to go up 8 units. So over here my vertex should say 0, 8. So then another example would be, this was another function we did yesterday, and we have g of x equals the absolute value of x plus 4. This time, if you notice, I do have something inside my absolute value with x. I have a plus 4 there. I don't, however, have anything on the outside like I did up here. There's nothing there. So again, my vertex should create or contain 0 in it. It's not going to create, or it's not going to contain a 0 from this part, but it will contain a 0 because there's nothing on the outside. And if we remember yesterday, I told you guys that this says x plus 4, but it implies that we are shifting this graph to the left 4 units. So if I'm shifting this graph to the left 4 units, then in my vertex, I represent that as -4, 0. Again, the 0 came because I did not have anything outside this absolute value. So there's my vertex, -4, 0. And one of our last problems to go over is if I have h of x equals -4 times x. Notice this time I don't have anything in the absolute value, nor do I have anything on the outside. Again, nothing inside besides an x, and nothing outside. So this time I have both zeros. I have x plus 0 in absolute value, and then plus 0 out here if I want to look at it that way. So my vertex is going to be 0, 0. And all that -4 right there does for me is tells me that my graph is going to be an upside down V, and that it is going to shrink. Remember that the bigger my number was, it shrank, and the smaller my number was, it kind of expanded. Okay, so we can summarize all this top part, we can summarize all of it into one basic absolute value formula, and it looks like this. We have f of x equals f of x equals a times the absolute value of x minus h plus k, where h comma k is my vertex. And if you go back, if you don't remember where h and k came from, example problems were right here. H in this case would be a 4, k in this case would be 8. So I also showed you that if you want in your notes, I would write it as it's the opposite h comma k. Because if you remember, in this up here, I had a positive 4, x plus 4. However, in my vertex, it became negative 4. So that's why I wrote down here, your vertex is at h comma k, but this also tells you that you take the opposite value of h and then whatever k is on the outside. And I also wrote down what a, h, and k tell you for this function. Or this formula. A is going to tell us whether I stretch or compress, meaning I shrink. And it's also going to tell me if I look like a normal V or an upside down V, depending on whether I'm positive or negative. H is going to tell me whether I shift left or right. And K is going to tell me whether I translate up or down. If you still have no idea how to identify the vertex based off of this video, I have attached a couple other videos on here as well. But if those do not help you, I highly suggest you do a YouTube search and look up how to identify the vertex in a absolute value function, and that should help you. Okay?